Well, welcome. Now we're going to get into logarithmic functions after we took a look at exponential functions. And there's three things that I want to cover right here at this moment. And the first is that a logarithmic function is the inverse of an exponential function. And so if you recall, let's go here with this, that on an exponential function, the variable was in the exponent. Now, once we get into graphing, which we will here in a couple of days, we'll see more of this logarithmic function being an inverse of an exponential function as we look at domain and range and x and y intercepts and asymptotes and in behavior, as well as increasing and decreasing. But we'll get a little bit more into that here in a couple of days. Now, this is something else, that a log or a logarithm is really an exponent. So what do I mean by that? Well, let's go back here again. Let's say if I've got an exponent, let's say 2 cubed equals 8. Well, we know that to be true. 2 cubed equals 8. And if we were to write this same expression in a logarithmic form, we would say that the log base 2 8 equals 3. And so here you can see that this log expression, that the log equals the exponent. All right, and let's see. Now, thirdly, we'll go here, and this is kind of what we can depend on, that the log of a base, and then the log of the base to what is the answer equals the exponent. So again, let's go back and look at this same thing that we just viewed. So if I've got 2, that's base 2 raised to a power of x equals 8. Then if I were to write that in logarithmic form, I would have log base 2 of 8 equals x. And if I'm going to set out to solve this, I can use this little curly Q thing. And then I could say that, okay, well, 8 equals 2 raised to the power of x. And from there, on this particular one, we can solve this because we know that 2 times 2 is 4, that's 2 squared, and 4 times 2, or 2 cubed, is equal to 8. All right, so the logarithmic function is an inverse of an exponential function. A log is an exponent, or a log is equal to an exponent. And as I'm evaluating these, I want to think about this right here. Log base of answer equals exponent. All right, we'll look at a couple of examples. You'll see what I mean. Okay, before we get into looking at some examples of evaluating or solving some logarithmic functions, let me just go over this right quick, make sure we're still here on the same page. So if we've got b is greater than 0, and b is not equal to 1, and x is greater than 0, then if we express this in logarithmic form, we've got log base b of x equals y, where b, we see here that b is the base and y is the exponent. And then looking at that in exponential form, again, we see that b raised to the power of y equals x, where b is the base and y is the exponent. And so here's how we relate the logarithmic and exponential functions. All right, now we're ready to look at some examples. All right, so let's look at evaluating some logarithms. And I am working here from the bottom of page 172 in your textbook. This is all in example 1, and it continues over to the very top of page 173. So here we've got this first one where we've got log base 3 of 81. And I guess maybe to try to be a little bit consistent with your book, I'll say it's equal to y, although I really like to use x better. But I can use this curly Q method here to help me with this. And I can then rewrite this to say, okay, base 3 raised to the power of y equals 81. So if you remember from that 2 slides back, the log base answer equals exponent. So I'm trying to solve for the exponent. Now, 3 raised to what power equals 81? Well, this is a little bit maybe more difficult possibly than we can do in our head. However, 3 times 3 is 9. That's 3 squared. Times 3 is 27. That's 3 cubed. And 27 times 3 is 81. And so y equals 4. All right, that's not too bad. Now let's look at this next one where we've got log base 5 of the square root of 5. And again, I'm going to put out here equals y or x, either one. So 5 raised to the power of y equals the square root of 5. Now, what power of 5 is going to give me a square root of 5? Well, under my law of exponents, you may remember that if I have a rational exponent, and in this case, let's say 1/2. So if I've got 5 raised to the 1/2 power, well, that is the same as saying that I am looking for, because remember, in this rational, what's in the denominator is the root, and what's in the numerator is what the number is raised to, the power it's raised to. And so in this case, 5 to the 1/2 is equal to the square root of 5. Okay, that's a little bit more complicated, but it's still not too bad. All right, what about this third one here? Log base 8 of 512. So again, I'm looking to solve for the exponent. This log is helping me solve for the exponent. So I've got 8 raised to the power of y equals 512. Now, like this first one right here, it might be a little bit more difficult to do in your head. But really what I'm asking is what is the power that 8 would be raised to, need to be raised to equal 512? Well, 8 squared is 64. I know that one pretty well. 8 times 8 is 64. And let's see, if I take 64 times 8, well, let's just see, 64 times 8, well, that's 32. 8 times 6 is 48, plus 3, 512, boom, there it is. So 8 raised to the third power equals 512, and then 3 is my answer because 3 is equal to y. Okay, we'll look at one more right quick. Now here you see I've got log base 4 of 4 raised to a power of 3.2. Now that looks really, really complicated. However, when I've got a log base, when I have a log to a base of that same number, in this case log base 4 of 4, well, these just cancel out. That's because of this inverse property of exponentials and logarithms. And so my answer is just simply 3.2. Because my log 4 and my 4 cancels out because those are the same. Okay. Now we got log base 2 of 1/32. Okay, so again, we're going to have to lean on our knowledge of exponents because really what I'm saying is I got 2, let me write it like this, do a little curly Q, 2 raised to the power of y is equal to 1/32. Okay, so what makes that base go into an exponent? In other words, if I'm raising a number by power that is putting that in the denominator, what have I actually done? Well, you may recall that means that I have raised it to a negative number. So let's say now I got now. So then really what I'm looking at is what power of 2 can give me 32, because I've already accounted for this negative right here. All right, well, 2 times 2 is 4. 4 times 2 is 8. That's cubed. 8 times 2 is 16. That's to the 4th power. And 16 times 2 is 32. And so my answer then will be y equals -5. So 2 raised to the -5th power is going to give me 1/32. All right, lastly in all this, again, I got a log base 16 of the square root of 2. So let's see, so now I've got 16 raised to the power of y equals the square root of 2. So what can give me that? So again, if you go back to what we looked at right here, that means that I have a rational or a fraction as an exponent. Because that's going to give me now. Here I've got 2, it's not raised to any power, so I can be pretty well assured that that means that my numerator is going to be 1. And so then I'm having to consider, okay, what is the power of, what do I have to raise to get to 16? Well, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and so that would be 4. And so y is equal to 1/4. Okay, may seem to be a little bit confusing. You just have to kind of be patient, think your way through it. But there we've taken a look at evaluating some logarithms.